All right, everybody, today we're looking at whether or not a function is invertible. All right, so I have a picture here with a couple of different functions. We have a function that kind of looks like a cubic function, which has a horizontal line passing through it. And we got a quadratic function where we have a horizontal line passing through it. Now, this is called the horizontal line test. And the horizontal line test works if and only if it only passes through once. So if it passes through once, we know that this function is a one-to-one function where each x value corresponds with one specific y value, and that would be an invertible function. This is a function, it's just not invertible because it has two different x values for the same y value. So what you probably would want to do is pause the video, draw these graphs so that you understand the concept of the horizontal line test. All right? Now, what we're going to do is we're going to go to Desmos real quick. I'm going to clear this out, and here we have a quadratic function. And a quadratic function is a function, but it's not invertible, because if I were to take a horizontal line and pass through it, it crosses it more than once. Okay? Now, what would be a function that would be considered invertible? All right? A linear function. So if I put a linear function, whether it's here or down here, this still passes the horizontal line test, which basically means if I have a horizontal line, it's only going to touch it once versus touching it twice. All right, so let's take a look at this real quick. We've got a quadratic function. It's not invertible because if you look and put x equals y squared, you can see that its inverse, if I do the inverse, if I swap the x's and y's, the inverse is not a function because it doesn't pass what's called the vertical line test, and you probably heard of the vertical line test before. So in review, if this doesn't pass the horizontal line test, which means it touches it more than once, then its inverse will not pass the vertical line test, where it crosses it more than once. All right? So that's the first concept that we're going to talk about. All right, what we're going to do is we're going to take a look at some Khan Academy here, and then we're going to determine if a function is invertible. All right, so let's take a look at these numbers. We got a that goes with 120, so we're going to say a goes with 120. B goes with 6 right there. C goes to 24. D goes to 2. And E goes to 1. All right? Now, this is considered to be what's called a one-to-one function. This would be a good example for your journal of where each x value has one specific y value that goes with it. And this would be a map. Okay? This would be a map that goes with it. I may have not put something where it needs to be. Hold on, let me check. Oh, okay. Ooh, I would have gotten that one wrong because I didn't move it right there on the 120. That would have been bad. All right, so there's the domain and range. So this is a map of the domain and range of what's considered to be a one-to-one function. And up here, I don't know if we can see it. I'll go back a page. Right here, here's a table of a one-to-one function where each x value has one corresponding y value. Now, what does that mean for us? That means yes, it is invertible because each x value goes specifically with one y value. Okay, let's take a look at this next one. Okay, so I'm going to try to zoom. Let me take a look at this real quick. All right, so here's the table. All right, there's the table. And then here's the map. Okay, here's the map. Now you can see, looks like these domain right here has the same, two different elements of the domain have the same y value. This is where you have a function, it's just not going to be an invertible function because B and E both go to 25 and C and D both go to the number 4. So we still have to go A goes with 1, B goes with 25, C goes with 4, boom. D, just kidding, C4, it was just a joke. D goes with 4, and E goes with 25. So if we look at this carefully, you can see that we have B and E both going to the same number. And we have C, which is an element of the domain. and d, which is an element of the domain. Okay? These are both elements of the domain that go to the same y value. Now this is a function. This is a functional relationship. However, this function cannot be inverted. So we call this, it's not invertible. Even though it's a function, it's not invertible. And that's what you're doing on this assignment. Okay? The next thing we're going to talk about is how do we restrict domains. Okay? So this is where it gets a little interesting. So we're going to look at this real quick. We're going to look at this picture. All right? And this whole function right here, this is a functional ratio. This whole thing is not invertible because it crosses it more than once, but we could restrict the domain to make it invertible. So what does that mean, to restrict the domain? So right now, I told you that this function right here, this quadratic function, is not invertible. But if I restrict the domain, I can make it invertible. If I just say x is greater than or equal to 0, then a horizontal line would only touch once, and it would make it invertible. Well, what would be the inverse of this function? It would be y equals the square root of x. And you can see that these are inverses because they reflect across y equals x. If we zoom in, we can see that this reflects across y equals x. Now, if I change the domain and say, okay, we're only going to graph less than or equal to 0, then its inverse would be y equals negative square root of x. And you can still see how this reflects across the across y equals x. So sometimes we have to restrict the domain in order for it to work. So let's take a look at this. We'll see if this works. From negative 10 to positive 4. So if we go from negative 10 to positive 4, let's see. So from negative 10 to positive 4, I don't touch it there, but I could touch it more than once right there. So I'm not going to select that answer choice from negative 10 all the way to positive 4 because I can touch it twice. So I'm not going to select that as my answer. How about from negative 6 to positive 6? See, here we go. From negative 6 to positive 6. If I go from negative 6 to positive 6, I touch it more than once there. I also touch it more than once right here from negative 6 to positive 6. So I'm not going to select that answer choice. From 0 to 10. From 0 to 10. Well, that only touches it once no matter where I put it. I like it. So from 0 to 10, no matter where I put this horizontal line, from 0 to 10, no matter where I put it, I could keep doing this all the way down. How many places does it touch, no matter what? It just touches it one time every single time from 0 to 10, no matter where I put it on the graph. So I feel pretty good that that's going to be the answer that I select. Okay? Ooh, here's a funky looking one. I like it. All right. So being that I like it, I'm going to go ahead and use my old snippet tool right here. Snipping tool. And you're just going to have to watch me snip because this is a good looking graph right here. So this could be a future good question. Don't worry, it won't take long. File. Let's just call it. Ooh, yeah, we'll call it a discontinuity graph. Look at discontinuity. There's some discontinuity going on there. All right, done with that. All right, so let's take a look at this domain. From negative 9 to negative 5. Let's look at negative 9 to negative 5. Negative 9 to negative 5. Oh, that hits it here and here. So if I were to go from negative 9 to negative 5, I can see it hits it twice. So I'm not going to select that one. All right, how about from negative 5 to negative 2? Negative 5 to negative 2, I can hit it twice right there from negative 5 to negative 2 right here. Let me look here. Yep, negative 5 to not including it though. Not including it. Oh, not including it. So it's not including this point, so it stops. So actually, you know what? From negative 5 to negative 2, it only touches it once. Oh, okay. So that one, I will select that one. I like it. Select that one. And then from what? 3 to 6. From 3 right here to 6, looks like that one will work. All right, so 3 to 6, from 3 to 6, because it's not including the 6, it only touches it once from here to there. So I'm going to select that one. I'm going to select that one. I'm not sure if I'm going to select this one. -9 to 5. -9, which is here. Oh, so that definitely crosses over from here to there. All right, so that's what you kind of have to do. You got to take your time and draw your horizontal lines to see if it works or doesn't work. Okay? So -4 to 0. -4 to 0 from here to here. It looks like it would touch twice, but it actually doesn't because it says it's not including the 0, so that one would work. -2 to +2. Let's look. -2, which is right there, to +2. It only touches it once, no matter where I put it. If you're wondering where -2 to +2 is, it's literally from here to here, all the way down. It only touches it technically once, all the way down, no matter where I touch it. So that's what you're doing. You're doing the horizontal line test from -2 to +2. So it only touches it once. So I'm going to select both of those, and then from 0 to 6. Okay, from 0, that touches it, to 6, that touches it right there at a 4, and it touches it past there. So I'm not going to select that one. So I'm only going to select these two. And that's how it works. Right? So what are you guys going to do? You're going to use what's called the what? The horizontal. Go all the way back to the beginning. We're using the horizontal line test. If it touches it twice, it's not invertible. If it touches it once, it is invertible. And we'll call it a day.